This section about classifying materials is divided into atomic structure, bonding, and properties of materials. First, atomic structure. All matter is made up of particles. Atoms are the simplest particles in an element. Each element is made up of only one type of atom. Atoms cannot be divided without changing the chemical nature of the substance. So, what goes on inside an atom?
A cloud of electrons surrounds a central nucleus. The electrons carry a negative electric charge. But right in the middle, the nucleus is positive because it contains a number of positive particles called protons. Also in the nucleus are neutrons, but they play only a small role in chemistry. Most of chemistry is about what happens outside the nucleus, what happens to the electrons.
So, every atom has a dense central nucleus containing positively charged protons and uncharged neutrons. The nucleus is surrounded by a cloud of much smaller, negatively charged electrons. The nucleus has nearly all the mass, but takes up less than 1% of the volume. 99% of the space inside the atom is empty. The positive charge on the protons equals the negative charge on the electrons, so overall the atom is neutral. There's a force of attraction between the positive protons and the negative electrons. This holds the electrons in place in the atom as they orbit around the nucleus. Protons and neutrons both have mass. They each have a mass of 1 in atomic mass units. The mass of an electron is so small, it can be ignored. All the atoms of one element have the same number of protons. Atoms of different elements have different numbers of protons. The number of protons in an element is called the proton number. This is the atomic structure of lithium on the left and carbon on the right. Lithium has a proton number of 3 because it has 3 protons. Carbon has a proton number of 6 because it has 6 protons. The number of electrons in an atom is the same as the number of protons. So lithium has 3 electrons and carbon has 6 electrons. The number of neutrons in the nucleus of an atom is usually, but not always, the same as the number of protons. So lithium has 3 neutrons and carbon has 6 neutrons. The proton number of an element is also called its atomic number. A carbon atom has 6 protons and a proton number of 6, so its atomic number is also 6. The mass number of an element is the number of protons plus the number of neutrons. Carbon has 6 protons and 6 neutrons, so has a mass number of 6 plus 6 equals 12. That's written C for carbon, with the atomic number, 6, above it, and the mass number, 12, below it. The mass number is usually twice the atomic number. An isotope is a version of the element with a different number of neutrons and protons. Normal carbon has 6 protons and 6 neutrons, giving an atomic mass number of 12. But there's an isotope of carbon found in much smaller quantities, with 6 protons and 8 neutrons, giving it an atomic mass number of 14. Isotopes of the same element have the same number of protons and the same atomic number. However, they have a different number of neutrons, and so have a different mass number. Back to the clip to find out more about electrons.
If it were possible to see an atom using a microscope, this is what one might look like. Squashed flat, the electron cloud would look like a set of rings called shells. 2 electrons are all it takes to fill the inner shell, but the next one out can hold up to 8.
So, electrons are arranged around the nucleus in different shells or energy levels. The first shell, nearest to the nucleus, holds up to 2 electrons. If it's 1 electron, it's hydrogen, and if it's 2, it's helium. The second shell can hold up to 8 electrons. It goes from lithium with 1 electron in the second shell up to neon with 8. The third shell can hold more than 8 electrons, but it sticks at 8, from sodium with 1 electron in the third shell to argon with 8. Electrons get as close to the nucleus as possible and fill the shells from the inner shell outwards. The addition of 1 electron in a shell makes a completely different element. The way elements react with each other depends on the number of electrons in the outer shells. There's more about this in the section on the periodic table in Patterns of Chemical Behaviour. Here's a question about atomic structure. These are the electron arrangements of some elements. Which element has an incorrect electron arrangement? Electrons normally fill their inner shell before the next shell can start filling. That means that element A, with only 1 electron in its inner shell, but 8 in its next shell, is wrong. It should be 2, 8, 2. Magnesium. Here's another question about atomic structure. An element has 9 electrons. Give the numbers of electrons that fit into each shell. Another element has 17 electrons. Give the numbers of electrons that fit into each shell. The first part of the question asks about an element with 9 electrons. The first electron shell can only hold a maximum of 2 electrons. That leaves 7 electrons to go into the next shell to give the total of 9. This is fluorine. The next part of the question asked about another element with 17 electrons. Again, the first electron shell can only hold a maximum of 2 electrons. The next shell can hold 8 electrons. That leaves 7 electrons to go into the third shell to give the total of 17. This is chlorine. That's the end of the section on atomic structure.